There is a very real chance that you've used a generator before in Python, perhaps even without knowing it. A lot of the Python standard lib is built on top of generators, and this whole idea of lazy computation or lazy iteration, which is what generators fall under, is really kind of a core concept of Python in a sense. It provides a flexible way to create potentially infinitely long series of values that don't take up a potentially infinitely large amount of memory. And that's because generators, as the name implies, generate the values in a sequence as and when they are needed. It's not like a list or a tuple where all the values need to be put into memory at the time that the thing is loaded or the list is loaded or whatever. Generators only use the memory that they need to use at the time because they only generate values as and when they're needed. I do quickly want to say that today is the 3-year anniversary of the channel. I've been doing this for 3 years. I haven't got anything special planned for today. Hopefully I'll get something done next week. I'm actually moving out of university this week. So everything is just kind of up in the air. I just didn't really have the time to do everything. As you can see, I've reformatted back into Windows 10 on top of everything else. So there hasn't really been any time to do anything special, but hopefully I'll have something next week for you. But in the meantime, generators are a really important concept in Python, and I'm surprised I haven't done a video about them yet. So I'm doing one today. So I said at the start that you may have used generator without realizing it. If you've never heard of generators before and you've used range before, not ramg, range, then you've used a generator. If I do for I in range 10 and I do print I, we can see that it runs perfectly fine. But if we then do just range 10, we can see that we just have a range between 0 and 10. It doesn't print a list or anything. If we print the type of it, it is a class of range. Now range is a specific thing. It is kind of a class in and of itself, but it acts very much like a generator insofar as the numbers are generated as and when they are needed. Hence you can have range stupid levels, like stupid numbers, and this will just work. I'm not gonna leave this to run, but we're not using any additional memory generating any of these numbers at all. We haven't loaded however many numbers this is, I don't even know, into memory, otherwise the whole thing would just crash. Instead, we are generating each and every one of these numbers as and when we need to, which is how we can get away with having these infinite sequences, as I say. Creating a generator isn't even that difficult. It kind of relies on already existing syntax. So we actually create a function to do it. And in this case, we're going to create a function that starts from 2 and returns the previous number doubled every single time up until n number of iterations. So we're going to do double and we're going to do n, and I'm just going to do kind of v equals 2, and then for I in range n yield v, and it would be times by 2, and then actually what we can do is just kind of do v times equals 2 and then yield v. That'll probably be easier. So what we're doing here is we're just setting v equals 2. Actually, we can probably set it equals 1, to be honest. And then for the number of steps that we say, we multiply the current value by 2 and then we yield it. So this yield is the generator equivalent of a return. And this yield kind of turns the function into a generator itself. So all you need to do is supply a yield. And what it does is when this yield is hit, it sort of returns the value back out into the rest of the code, but the execution state is saved. And then once you go into the next element, it then runs through this again up until it gets a yield. So you can have a yield in the middle. I think there was a video recently that had to use a yield. I don't remember which one it was though. But you can have a yield in the middle of a function. You can have a yield right at the start if you really wanted to. But this yields, as I say, saves the execution function and then or saves the execution state of the function and allows you to iterate through it. While trying to plan on this video, I kind of realized that I should yield the 1 as the first element really first. So it now yields the 1 and then it goes into here and then yields everything beyond that. Again, this is perfectly fine. You could just have multiple yields in a function and it'll work just fine. There are multiple ways of accessing the next value in a generator. So the first of which you could just use the next built in. If you ever wonder what this does, then this is what it does itself. And then we can have, say gen equals double 5. if we just print gen for a second, actually, before I go into this next thing, you can see that it prints a generator object double. So this is our actual generator object. So you can see that nothing is loaded really into memory. All we have is the actual generator function itself. We can't actually access individual elements. If I tried to access the second element, we wouldn't get anywhere. It's not subscriptable. What we'd need to do is we need to use this next to actually access the next element in the array. And then we can do this multiple times, and we can see that we have 1, 2, and 4. So once a value is consumed, it is lost. Unless you save it somewhere else, it is lost. And then this next would then call, so the execution state would be saved here after this one. After this one, it would then move into this for loop, but it would be saved here. And then once you run this one, it would go back into this for loop, and then it will keep going, and it would, run this again, and it will just kind of do this forever, really. The other way you can do it is by doing, say, for I in range 5. We can do, actually no, it'd be for I in double 5. Sorry. No, I didn't tell you to put a capital there. And then print I. Do that as it will print 6 elements. That's interesting. Oh, because this needs to be n-1 now, doesn't it? There we go. So it now prints 5 elements. If we did this with 10, it would print, our 10 elements. If we did this with a stupid number again, then it would start printing out, very ridiculous numbers very quickly. I'm going to stop that before it has a bit of a heart attack. But you can see, again, we're not loading all of these values into memory. We're generating them as time goes on. The other way to do this is by using something called generator comprehension. Now, I don't actually remember if I've done a video on list comprehension or not. If I have, it'll be up in the cards. If I haven't, then there'll probably be a video on the channel quite soon about it, because I feel as though I should have done it if I haven't. So, I'll make good on that if I haven't done it yet. But generator comprehension essentially works the same as list comprehension for those of you that know about it, except instead of using square brackets, you use normal brackets, or if you're in America, parentheses. But other than that, they are pretty much the same. And a common use case, or at least the most common use case I can think of right now, is when using the any or the all built-in methods. You can create a generator comprehension that essentially evaluates a series of values and then kind of yields the Boolean, whether it's true or false, and then you can pass that into any or all, and it will do the rest of the computations to make sure that everything's fine. What you can do, say for example, is I modulo 2 double equals 0 for I in range 20, and then if we just say this is like gen for now, I suppose. And then we print gen, and we actually comment this out so we're not getting annoyed. You can see there is just another generator object. Because it's, it doesn't have a function name, it's just called genexpr, or generator expression. I'm not even sure if it's called generator comprehension officially. I just like calling it that. I find it quite fun. But we can see that if we do, next gen, and the same thing again. Is it true, false, true? It works exactly the same way, essentially. So we can do for I in range gen, print I. Generator object cannot be interpreted as an integer because it's not a range, it's just a gen. And we can see, true, false, as you would expect with, something that checks if something is even or not. But in terms of the actual use case I was suggesting, what you could do is, if all, and then have this in here. And you don't even need, parentheses or brackets around this. Print true, else print false. As we all know, this is going to print false. But if we just get rid of this, so you don't actually need brackets around this bit at all. You can just have, your all and your expression in here, and Python will default to a generator expression. If you wanted it to be a list comprehension, then you could do it something like that, and then it will work the same. But if we run this now, then it will say false, because obviously There are odd numbers between 1 and 20. I suppose it would be between 0 and 19, wouldn't it, in this case? But we don't need to get bogged down with the specifics of that. So that is basically everything that I wanted to talk about generators. As I said, they are incredibly useful. You've probably used one or two of them without even realizing. And if you haven't used them before, then you really should be using them because they are just great. They are fantastic in all sorts of ways. Of course, if you like the video, then consider liking to let me know, and maybe subscribing if you really enjoyed the video. If you have any questions, feel free to leave them in the comments below. If you have any ideas about future videos, especially list comprehensions if I haven't done that yet, then do leave them down there too. I'm always open for ideas, so feel free to hit me with them. If you feel like supporting the channel a little bit more, then you can either hit the join button down below or use the link in the description to pledge on the Patreon. £1 a month for either, and you could be on the screen like these people. And I will see you in the next video, where, well, it will probably be the 3-year anniversary video. Week late. Sorry about that. Again, moving out and everything. There won't be any other videos this week for that reason as well. So yeah, sorry about that. But you know, YouTube is full of amazing people, so go check some of them out. Also, I'll see you later.